Okay, let me get the lights adjusted. Okay, so what I've done here in RAM is I kind of recreated the building that we did the other day, but I mean, I was just throwing together numbers, you know, just for the heck of it. So there's nothing in this. That is. Don't take any of this to the bank. I just threw some numbers together, but I want to show you what's going on with the lateral system. Now, does anybody remember from steel design the two main types of lateral systems that we use in buildings? Brace frames and moment frames. Good. Do we put brace frames and moment frames everywhere?
No.
No, right? We only put them in very specific locations. So let me show you something, all right? Let's take a look at this floor plan, and I might just use the floor plan everywhere just to sort of illustrate the visuals of what I'm talking about. So let's go ahead. So here's my floor plan. Let's lay out some, here, let me go into story. I think I put a roof in here, but I'm just going to delete that because I just want to show you what I'm talking about. It doesn't really matter. Okay, so let's lay out some columns. Let's add those on grid. Now, if you notice, one thing I ignored in our last video is this part right here where it says gravity and lateral, okay? I'm not going to ignore that this time. I'm actually going to specify some lateral columns and some gravity columns. Now, gravity columns are basically everywhere. All columns are gravity columns because they all have to support vertical load. But only a few of them are lateral columns. Now, if you remember, usually like a moment frame is only on, it's usually like only on one line on each side of the building, and it only exists for a few bays. So here's what I'm going to do. I'm going to put gravity columns for the most part everywhere. So let's put them here. Well, here, let's put them, you know, all through the main part of the building. Let's put them on the corners and maybe like here. Maybe there. Okay. Now what I'm going to do is I'm going to add another set of columns, so layout, columns, add on grid, but I'm going to lay out some lateral columns. Okay, and I'm going to lay out lateral columns on all the other locations. So maybe here, 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 and here. Now if you notice, what do the columns look like? They're red, right? If I render the structure, I haven't put any beams on it, but you can see right off the bat that not all of the columns are the same, right? Some of the columns are lateral columns and some of them are gravity columns, okay? Now I'm going to do the same thing for the beams. I'm going to try and create lateral beams that would tie into these, basically making moment frames, okay? So let's see what's going on here. Okay, so let me close this. So let's add some beams on grid. We'll do gravity beams first. So fence. Let's do that. Let's do that, 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 that. Let's see. Let's do these. Okay, what else am I missing? Maybe these. You'll sort of notice where I'm leaving the gaps here. Okay, and then what I'm going to do is I'm going to go into layout, beams, add on grid, and let's add some lateral beams. So fence. Fence, say a fence here, a fence here. Now, just to make the visuals a little easier, let me do a slab so that when I render the building, we can see the floor slab. So let's go to material, or no, prop table. Let's go to decking. Let's add a floor slab. So we'll say floor slab. Let's say it's 3 inches above the flutes. Stud length's 4.5. What the heck, let's just leave everything else the same. Now I'm going through this kind of quickly because I showed you all this last time. It's in the, and I'm recording now, so I'm going to do this quickly. So let's do a slab edge. Let's do a 6-inch overhang across the whole perimeter, and let's assign that deck to the whole floor. Okay, so when I render the building, here's what I've got, okay? So I've got the floor slab everywhere, but I really want to pay attention to the columns, okay? Notice how I've got columns all over the place, but there's a difference between the gravity columns and the lateral columns. Everybody with me on that? Okay. Just to complete the picture, let me do something real quick. Let me do my, let's go to layout, beams, add generation, gravity. Let's do 4. Okay. There we go. Okay. Everybody with me? Now, here's the conceptual mistake that I think a lot of people made. Okay? The lateral columns. They're the only ones that are in the moment frame. Okay? What I mean by that, they're the only ones that you use the alignment chart on. You know, you have the GA and the GB, and you draw your line. That's just the red ones. For all the others, K equals 1. Because they're not holding up the building under lateral loads. So that is something I'm not going to make you fix moving forward, but when you check your column sizes, they're going to come out smaller. RAM's going to spit out a smaller size because it's taking K to be 1. You're not taking K to be 1. You're taking KY to be 1 and KX to be whatever, you know, 1.8 whatever. So your columns are going to be smaller in RAM than what you all did by hand, and that's why, okay? And if you want to get fancy, you can go in here and you can put in like chevron braces and make this a braced frame. So you could go in and say, you know, this over here on the x-axis, that's your moment frame, that's your braced frame. I'm actually going to let you all do whatever you want on that. I'm going to leave it open. So it's not quite an alternatives phase, but maybe it's another mini alternatives phase. But you got to brace the building, because if not, the building's going to fall over once somebody goes like that. So.
What kind of, I don't know how to ask it. How do you know what's enough? How do you know what you need?
That's a great question. Maybe Friday we ought to talk about wind loads. Oh goodness. We're going to talk about wind loads on Friday, but yes. I'm saying that you've got a building that's single-story, multi-story, and you got to figure out a way of restraining it north, south, east, west from winds. You can put moment frames or brace frames.
You only have to put moment frames, right? Wasn't that a requirement from the beginning to do only moment frames because of the wind resistance?
No.
Oh.
No. No, no.
This is a holy project.
What's that?
This is a holy project.
No, let me say this. There are reasons to go with moment frames versus brace frames. You do not have to use moment frames everywhere or brace frames everywhere. You can use a mix, okay? One is going to be more expensive than the other. But on the flip side, one is going to provide more access than the other. I'm going to leave it at that. Yeah, the way that RAM is treating the software, it's saying that everything that's red is meant to hold up the structure against wind or seismic. Everything that's blue is just going along for the ride, okay? Now, whether or not you put braces in there or not is up to you, okay? What RAM will do is decide if you do not put braces there, it's going to say moment frame. Now don't worry, this is not like, I think you all are like, oh my God, this turned into like 97 weeks worth of work and we only have 2 weeks. It's not that much work considering what you've already done. But Friday we'll talk about specifically, we'll talk about the specific wind load provisions, what you all need to know for the scope of your project. We did this in steel design. We talked about this. It's been a while, but we did talk about it. So if you haven't had steel, don't worry. We will talk about it. Remember, it was like 0.00256 kz, kzt, v squared. There we go. He remembered. Yeah, Bernoulli's equation. It's just Bernoulli's equation for air, right? You get pressure on one side, velocity on the other. Solve for the pressure. If you've got the fluid, a fluid of air, then throw in a unit conversion to take miles per hour winds and convert it into pounds per square foot. Boom. Y'all remember this. If not, don't worry. We'll cover it. You got this. That's a good question. So what you do is right here where it says layout horizontal brace. Or no, that's on the floor plan side. Let me close this. Okay, so what you've got to do is go into right here where it says frame design. Actually, hold on. This isn't going to work. I haven't designed the beams and the frames yet, or the beams and the columns yet. Now I didn't put, you got to understand, I didn't put any live loads on this structure at all. I didn't put any snow loads on it. I just created something. So these columns and beams are going to be really weird. Okay, all right. Now we go into frame design. Okay, all right. And then, let's see. In elevation view. There we go. Okay, so this is an elevation view. Oh, I think I drew it through the building. Let me see something. Come on. Come on. I know, I need a samurai sword and or a lightsaber. Let me see something.
Or a cake cutter if it's your birthday and you happen to be a doctor.
God. Tell you what, I can, if you want, I can show you this on Friday, but let me see something. Assign, braces, buckling restrained. Let's see, assign, column, horizontal braces. Oh, well, I'll look at this. I think it's a little more involved, but what we've got to do is we have to assign our frame numbers, and then for each frame number, we can draw in braces. And I know there's a few different options, but yeah, well, I don't have like, it's going to take longer than 10 minutes. I'll just show you this on Friday. So. What's that? But hold on, let me ask you this. How many of you have done your gravity model or started your gravity model yet? Good. Y'all need to start that. I thought somebody else raised their hand.
No.
You said no. No. Guys. FERPA. What? Okay, let's move on. Let's move on. All right, let's move on. I'm going to close all of this. All right, tell you what I will do. I will take this frame and probably add some vertical loads to it and maybe actually frame a roof on it. And then I'll show you all how to do lateral, because I think even if we go about this, I think we're going to get some weird sizes because I didn't put any vertical loads on it, and I think it's going to come out a little weird. So let me handle that later. In the meantime, any other questions about what your responsibilities are between now and, draft final?
Well, do we need to go for the deck? Do we need to go in? We have to, just whatever, new deck comes
Yeah. No, I mean, you've got your deck design guides like Volcraft and what have you. Just find one that works and then model that. Well, I'm talking about your beam spacing. So you've got beam spacing, of whatever. Let's say it's 12 feet. So that beam spacing, take that beam spacing and your allowable load, and you can figure out what deck pan works, model that deck pan in RAM, and then RAM will size your beams. Yeah.
I lost the whole for a second. I forgot what I was going to ask.
Your second is up. Just kidding.
Okay. You mentioned something before, because we had a 6-inch slab. You're like, oh, that can be reduced to like 3 and 4. What's reducing it to 3 and 4?
The fact that the slab is not sitting directly on top of the beam because of the flutes, you have that slab up, so moment arm.
Can I just, okay, I don't know how to decide. Like, can I just say that it's 3 inches?
No, that's what, hold on, everybody needs to listen to this. That's what I was saying in the Volcraft guide. In the Volcraft guide, it will list, okay, based on your span length, based on whether or not you're dealing with a composite floor system, and based on your applied load, you can select the appropriate deck system. Once you select that deck system, model that deck system in RAM, and then it will size your beams for you.
On the guide itself, it'll tell us how much concrete, like how many inches thick, right? Is that what you're saying? Because you had to input like, oh, like 4 inches.
That's in the guide, yes.
Okay.
So you'll have various different deck systems, and based on that deck system, you say, okay, here's the one we use. We know the concrete above the flutes is 4 inches thick. We know the flutes are 3 inches thick. We know this, and so on and so forth, and you can model that.
Okay. And what are we gonna have to worry about, like, bolts and connections and welding?
No. We might be able to handle that through RAM because we can take our model, and depending upon time, because there is going to be something to be said about time, but depending on time, if we get our RAM done early enough, we can import the RAM model into RAM connection or RAM elements. Should be able to size that for us. But I'm hesitant to say that we will do that because I need to see how time goes. So
When are we doing stuff with foundations?
let's see how we move forward on this. Because we got lateral frame and resizing of members and RAM models to do. So that'll keep you all busy, I promise. Finally, you trust me, after all these years.
I don't know, you're kind of contradicting. No, this is the easy part. Oh, you have so much easy.
Maybe I'm bluffing. Maybe I'm bluffing.
You're confused.
It's senior design. It's going to be the last time I have a lot of you in class. I got to have some fun with it. What's that?
Yeah, if you do timber design, we might come back.
I'm not teaching timber next semester. I'm teaching deformables next semester. So. I've asked about that, and I think, yes, we got to add that. There's folks that need it. Yeah. You need to bring that up to the chair, but
Okay, turn it up.
okay.
Yep.
Oh, Jesus. I love this job. I do.
Hey, this job loves you. By this job, I mean us. I don't know about the rest of
Okay. On Friday, we'll talk about wind loads and lateral effects in buildings. My advice to everyone here, you really ought to get some head work done on addressing your report edits, getting your RAM model done. You know, let me say this. Let me be absolutely sincere, okay? I wasn't kidding when I said that this phase should go a little more smoothly than your alternatives phase for two reasons. One, you've already figured out your team dynamic for the most part by now because you all have worked together closely for the first part of the semester. So you don't have that to go through. And second, it really isn't as much work, okay? It really isn't. But let me qualify that by saying it's not zero work. You do have stuff to do, okay? So don't wait until the last minute. You know, take your time. I saw there was a funny comment, I think it was on Reddit, say if you wait till the last minute, it only takes a minute. So, but I was like, that's pretty good. I hadn't heard that one yet. But don't wait, seriously, don't wait until the last minute. Spread this out, and I promise you it's not that bad. But like anything, if you put it off, it's going to creep up on you. So spread it out, do the work over time, and this will be a smooth final design phase. That's all I got. I'll see y'all on Friday.